And here we go. Welcome to CSCI 1, everybody. Hopefully we're all in the right spot. I don't like to make my presentations full screen. If you've never taken a class from me before, I have to say this because we're losing valuable screen space, I know, but it's worth it because I get much cooler pens this way if I don't make it full screen. I get rainbow pens, etc. And then also I'll be moving around between different programs since we'll be programming. Can't do that on PowerPoint. So that's why I keep it like this. First things first, besides recording everything, I'm going to give you these slides as a PDF and all the code that I write on Canvas once we get to that. So feel free to just sit back. You don't have to write down as much as you might think you do. Just write down what you want to remember rather than like my every word. Okay? So that's what we're going to do. And then today is that standard first lecture day. Like I'll introduce myself a little bit. We'll talk about the class and like we'll go to the grading section of the syllabus, the stuff that I know you care about. And then we'll talk a little bit about computer science. I'll give you some history of it. And then this is also a critical thinking class, so we're going to have some ethics to end us off with as well. So yeah, if you have any questions at any time, please shout them out or raise your hand, whatever you feel like doing. I like to run my classes like a little bit of a discussion, especially this critical thinking style class, okay? So I like to have a conversation with you rather than me just shouting out to you for an hour. It's no fun. So yeah, a little bit about me. Hello everyone, my name is Lawton Nichols. I use he, him pronouns, and I will respond to whatever you guys want to call me. So call me Mr. Nichols, call me Dr. Nichols, call me Professor Nichols. But honestly, if you feel like it, I would prefer it if you just like drop all these things and call me by my first name. Please call me Lawton. I don't want your fake respect. I want to earn your real respect, right? So if you're comfortable with that, please call me Lawton. And so a little bit about my background is I went to Fresno State, not too far away from my undergrad, and then I went to UCSB, UC Santa Barbara, for grad school for my master's and my PhD. Every one of my degrees is in computer science, so hopefully that means I can teach you a little bit of something. And yeah, it's my fourth year here. We're in the spring now, and I like to be a human and do non-teaching things too. I like to dance, I like to play guitar, I like to just chill with my cat. His name is Lonzo, by the way. He's named after Alonzo Church, who was the PhD advisor of Alan Turing. So you probably heard of Alan Turing, I hope. Please look him up if you have not. He's very famous in computer science, and Alonzo Church was the dude who like helped him become as cool as he became. So yeah, I've dedicated my firstborn son to computer science. I love him. He's much larger now. That's when he was a kid. So yeah, we live in this weird, awkward time post-COVID. So just thank you in advance for putting up with me. We'll get through this semester together, right? We'll figure something out. And yeah, that's a little bit about me. Let's talk about the class. So I'm going to go very fast during this section because we're all going to fall asleep, me included, if we stay here too long. Remember that it's your job to read that syllabus. Hopefully you've looked at it already. But I'm going to go and give you the highlights. All right. So this class is an in-person class, and so I'm required to take attendance. Okay. We're going to do that in just a second. I have a cool way of doing it. My drop policy is that if you miss 3 consecutive classes, I'm going to drop you. Also, if you miss the first class, you will be dropped. None of you are going to be dropped because you're all here right now, okay? But that's my policy after the first day. So I'm pretty lenient, though. Like, if something happens, like, we understand that things can get in the way. So just let me know, like, if something comes up, like you have a doctor's appointment or something that's an emergency, and I will excuse that absence, and it won't count towards those 3 consecutive classes, okay? So just keep that in mind. I do have to drop people if they stop showing up because of money things. The school gets on professors for that kind of stuff because we get less money if you stop showing up. Okay, so with that, let's talk about expectations. This is a 3-unit general education class, so it's nothing like my other computer science classes, the major level ones that I teach. So this class is not meant to be hard, but it's going to be a different way of thinking. You're going to have to do a decent amount of work just to learn the material. So just mentally prepare for that, all right? If you've never programmed before or done any computer science stuff, I don't expect you to have, but it's going to be a little bit hard to suck all that stuff into your brain at the beginning, okay? It's going to be fun, though, I promise. I enjoy it. Programming just in general, if you've never done it before, it's a brand new way of thinking about stuff. It's thinking logically. That's why this is kind of connected with a critical thinking class. But yeah, please do the work as it gets assigned, because if you wait until the last minute, just like look around the room as I say this anecdote, if you have already taken a computer science class by now, you will know that if you wait till the last minute to do something, it will not work out for you. All right? You have to spend some time just churning all the ideas in your mind to make things work. Okay? With that, though, the class is not about memorizing anything at all. I'm going to teach you a new way of thinking, and then that's going to allow you to pretty much write any program you want to write, or think in a different way, and write any essay that you want to write. All right? So it's not about memorizing. Maybe that's a good thing or a bad thing, depending on how you view that. But you can't really memorize anything and expect to do well on the test. It's more about learning a different way of thinking. Right? So it's pretty nice. You don't have to write a bunch of stuff down. You just have to do the work. Right? And I'm not here to scare you away or anything. I just want to make sure you understand what you're in for, because I'm, of course, here to help you. I'm here to teach you and make sure you learn, as to the best of my abilities, at least. All right? So yeah, that's expectations. Are we good? Any questions? Please just shout them out. Raise your hand if you have any. Hopefully it's pretty self-explanatory for now, at least. One thing that's big that started during COVID was the school, if you don't know about it, through the library, there's a technology loan program. If you need like a laptop to do your work on, if you need, if the internet connection at your house is spotty, they are renting out little hotspot routers through the library, even graphing calculators for other classes and stuff. So look into this. We have a resources page on our Canvas modules. If you need this, it will help you succeed in the class, and you deserve this stuff. So take advantage of it if you need it. Yeah. So just a short sneak peek of what we're going to be talking about. All these slides, we're going to go pretty fast, right, until we get to the real stuff. So this class is about a few different things. It's a weird combination of computer science and I would say philosophy. If you look at the requirements, I did not write those requirements. I don't like some of them, but we're going to learn them. All right. So the biggest thing we're going to learn in this class is computational thinking. That's like thinking like a computer. And that kind of, we're going to build that through learning more about critical thinking, because this is a critical thinking general education class, right? We're going to learn how to like write good arguments and talk about what it means to think logically. A certain type of incorrect thinking is arguments that contain fallacies. I'll have a whole essay about that later in the class. It'll be fun. I'll force you guys to debate each other in a nice way. But we're going to have to think about some hard topics, and that's going to help us with our computational thinking. And so they kind of go together, and it'll make us a better programmer, learning how to argue and think logically. Okay? We're going to try to tie it back to computer science as best as we can. So there's a lot of issues in computer science that we could write essays about, I'm sure you can imagine. Ethical dilemmas, you got AI, of course, is the hot topic. Cryptocurrency used to be the old hot topic, right? So we have plenty of things we can talk about and explore and analyze. So makes for a good critical thinking class, in my opinion, though I am very, very biased. All right, so this class is pretty much for anybody who wants to be here. You don't have to have a certain skill. I don't imagine that you're all programmers or anything. I'm glad that you're here. So this class is for anybody who wants to be to dip their toes into programming, learn more about computational thinking, get better at problem solving on the way, because that's what computer science is. A degree in computer science, in my opinion, is a degree in just critical thinking logically. All right. If you're here because you need a GE critical thinking class, that's fine. Okay, just do the work and you'll do great. All right. And then if you are a computer science major already, you've drunk the Kool-Aid, and you just want to know a little bit more. You want to zoom out, look at the bigger picture, rather than just like have your head down and write programs all day long. There's more to it, and we're gonna talk about the interconnectedness of computer science to the rest of the world. So that'll be fun. All right. We still doing okay? All right. So let's go to the place we probably all want to go right now. Let's talk about the syllabus. Hopefully we've discovered that to look at all these things, we got to go to the modules page. I forced you to look at every page. All right, that's what's going on here. Complete all items. And then we have the week 1 available right now. So syllabus is here. That's one way to get here. And let's scroll down to the place that you care most about, I would say. The grade breakdown. Did I go too far? Yeah. All right, so here is the grade breakdown. Let's see, how do I want to do this? the first kind of assignment I've already released. Have we seen the check-in survey? Week 1 check-in survey. See that that's out? Have we all been able to access it? So that'll be due on Friday at 5:30. We'll talk about that in a little bit. But this used to be the way I took attendance in my online classes, but it's just so nice. It helps me understand you. So check-in surveys are going to be 5% of your grade in this class. I'm going to give you one every week, and it's me forcing you to psychoanalyze yourselves. I'm going to ask you, after this week, I'm going to start asking you, like, what are you struggling on? How do you think you could improve? Stuff like that. And so it's going to help me understand where you're struggling, and then also it'll help you figure out how to fix that. So it's really helpful, I think. And so it's an easy 5% of your grade. Just do every check-in survey. Okay? So the first one's out. What else? What else? So that's 5% of your grade over here. Let's just do it in this order. So essays is another feature of this class. I never thought I'd have to grade essays as a computer science professor, but here we are. So I'm not happy about this, but I'm going to have to force you, to write 6,000 words of essays in total across this semester. All right, so just mentally prepare yourself for that. If you don't like writing essays, you have to write essays in this class, and it's a big portion of your grade. All right, 30% of your grade will be from written essays, and some will be like mini essays. The first one will be like Canvas little discussions and things like that. So that's 30% of your grade, so please do those. And then the other half of this class, like it's half philosophy, logic, half programming. So the other big chunk of your grade is going to come from programming assignments that you will be getting most weeks. We're going to start out with the Scratch language, then get into the Python language. If you've already learned how to program, if you've taken another computer science class or you've learned programming before, I'm going to give you different assignments, so pay attention when I give the first assignment out, because the first assignment for you, if you've already programmed before, would be too easy, and that wouldn't be fair. Okay, so just keep your head up for that, and so that'll be another 30% of your final grade. Okay, programming assignments. Let's see what else. What else? We got one midterm in this class. It'll be halfway through the semester, so this is like there's 18 weeks. No, there's 17 weeks. I can't remember. There's like 17 or 18 weeks of class, and week 8 is about halfway. All right, so that'll be when our midterm is, and that's that. And then 20% of your grade will be from a final exam. All right, and I'll talk more about those as we get closer to them. Let's see. Is that everything I wanted to say about that? I think so. Oh, we got to talk about the date of the final, but we'll do that in just a second. I do recommend a textbook. I don't require a textbook. I hope you saw that on the syllabus. The book is how I've structured the philosophy part of the class. If you read the book and you get it, it will help you on the essays, definitely, and like studying for the exams, but you don't have to buy it. I'm not going to force you to. It can only help if you feel like buying it, though. So there's that. And so that was all of that. There will also be extra credit. I'm going to give you guys some extra credit opportunities throughout the class, up to a maximum of 10% extra credit, because here's what I'm going to do. I'm going to give you a few extra credit assignments in this class, and then also a new thing that I'm doing this semester for my students is, if you've joined the Discord, you've seen this, hopefully, I will give half a percentage point on your final grade of extra credit for going to any ACM club workshop, and those will be released announced throughout the semester on the ACM Discord. So in the welcome channel of my Discord, which hopefully you've joined by now, there is a link to join the ACM Club Discord, and there's a workshops channel that you can watch for that. All right, so just go hang out and learn some computer science for half an extra credit point. Okay, so consider that. And then because I'll be giving a decent amount of extra credit here as well, you can't like double dip too much. You can only get up to a maximum of one letter grade of extra credit. Okay, that's what I'm cutting you off. So that's what I want to say there. And then finally, the final exam date, because we have a scheduled time for this class, there's a scheduled time for our final. So our final exam, if I'm reading the table right, will be on Monday, the 13th of May, so the Monday of finals week, right at the beginning, from 4 to 5:50. So it's a little bit longer than class. It'll be in this room. Okay, so that's when our final exam will be. Any questions about that? Because this is probably the most important slide to a lot of us, I can imagine. Does that make enough sense? All right. So, yeah, more policy stuff, and then we'll get to good stuff, I promise. Let's talk about late submissions. I'm pretty lenient with late submissions. I will accept late programming assignments and check-in surveys up to the last day of instruction. So if you miss a week, like, you can make it up way later if you want to. But the trade-off there is I'm going to take away half credit. the second it's late. Okay, so that I hope is fair to you. But you can turn programming assignments and check-in surveys up late up until the last day of instruction, not the last day of finals week, last day of classes. Okay, for a 50% penalty. The one thing I won't accept late is essays, because those take forever to grade. I hope you can imagine that. I don't want to get like a million essays right as I'm trying to like grade the final assignments in this class and make a final. So I'm not accepting late essays. I'm going to cut you off there. Yeah, so that's late submission, my late policy. Take advantage of it. Also, due dates. I do things a bit differently to some professors. So mentally prepare. Every assignment in this class, except for the check-in surveys, which will be due at 5:30 on Fridays, will be due at 5 p.m. All right? That makes sure that, I think if you've taken a computer science class, you'll understand, or you will understand soon, things go wrong when you're programming and you're having issues. So I will be awake as you have those issues close to the due date if we do it this way. And so that's why I'm doing it, doing the due dates at 5 p.m. So just remember, if you see a due date, Canvas will tell you. It should tell you the time. Just remember, it's not midnight. It is 5 p.m. Okay? Yes?
All assignments are due on Fridays?
No, only the check-in surveys will be due on Fridays. The assignments will be due like Tuesdays or Thursdays, like in between class days. But it'll all be on Canvas. Yeah. I do make some exceptions to this rule, though. So let me know after class if any of these apply to you, and I'll get you in the right bucket. But if you work at least half-time, 20 hours a week, school does not count, by the way. If you're taking 20 units, that is completely your fault, right? Some of us have to work, though. So I'll extend your due dates an extra 7 hours if you work at least half-time, 20 hours a week. And so your due dates really will be midnight in that case, right? And then if you work at least full-time, greater than or equal to 40 hours per week, or you do something that is the equivalent of a full-time job, like you care for a child, then I will extend your due dates by an extra 15 hours. So you can either like stay up late or wake up early and get the assignment in, and it's a bit more flexible. So hopefully we can agree that people in these categories deserve the extra time, and just let me know if any of those apply to you. Okay, so that's that. That's my due date policy. And then I'll drop a few lowest scores. I'll drop your 3 lowest programming assignments. I got to keep the essays because you're required to write all 6,000 words, sadly. So programming assignments, I'll drop 3 of them. Okay, I want you to use Discord. Let me start it up because it's going to take forever to start up as I explain it. I would like you to use Discord for discussing things and asking questions, just to me and also all to your peers. So on Discord, when you get here, as it installs its many updates, when it opens up, when you join our class Discord through the link, hopefully we've already all done this, but it'll give you the welcome channel and the guide channel. The welcome channel, you want to scroll up to the top and like click the 100 emoji, and that will add like the general channel to you and like the random channel. Then there's also an animal emoji, and I forget which one, that you'll click to add the CSCI 1 channel. And I'll show that to you in just a second. But we're going to have our own CSCI 1 channel that you can make public posts to. Yeah, question?
Discord says
okay, yeah, I'll show you how to get into that. The link should work.
You just have to view all the items first?
Yeah, you had to view all the items on campus, yes. I'm forcing you to look at every page. And so we're moving at the speed of JavaScript right now. We'll get it there in just a second. There we go. Okay, cool. So here we go. Here's my server right there. Here's the ACM Club server. They have their workshops channel that you wanna look at right there, workshops. But here's my server. When you get here, it's the welcome channel. You scroll up to the tippy top, click the 100 emoji, click the dog to add the CSCI 1 channel after that, and then you can add your pronouns. And here's also the link to the ACM Club Discord. So yeah, this will be your CSCI 1 channel where you can like ask public questions and talk to me. All right? What I don't want you to do is share a ton of code or your complete answers publicly. Okay, that would be very unfair. I hope we can just use our judgment, right? Don't give away an answer. Any kind of question that involves giving away a lot of stuff should just be a private message to me. But do it on Discord still, all right? So you can always privately ask me questions through a direct message. You can right-click on me. There's a message option will appear. I just can't message myself, all right? But I could message Max right here if I wanted to. There's a message. Cool. So do that for anything that would be not good to post publicly, okay? So that's that. Let's see. And I highly, highly encourage you to use Discord to contact me instead of email. I've gotten like 20 emails from students trying to add my classes just today, you guys. My email is disgusting. But you can see how easy it is for you to notice, like, oh, I have to respond to this student. See that? So use Discord, please. So that's that. And yeah, get joined. I can help you if you're having trouble after class. There's that. There is also office hours where I can help you on Zoom or in person because I have some online classes, and so I do have, every time I have office hours, like here's my office hours schedule, or at least when I want to have it. This might change, just check this every time. But like here, the screen section, after class today, I will be having office hours. If you'd like to follow me to my office or run home and go on Zoom, either way works, right? If you want to come to my Zoom office hours, also on Friday I have office hours from 4 to 5. 4 to 5, 4:50. To go to my office hours on Zoom if you're ever not here or just want to go home, you click this link or this link. Either one. We'll take you there. Okay? But I also have my office upstairs here in this building. So that's when my office hours are. Come get help, ask questions. And the schedule might change because meetings are getting scheduled this week for professors right now. So that's when I want to have my office hours at least. So you should have a lot of options. Both days after class, if you want to follow me. Okay, before we take attendance, I just want to say one thing. This is very key to computer science classes. If you've never taken one, I just want to drive it hard into your brains. You are going to get stuck in this class on a programming assignment, especially. All right? I want you to ask for help. There's no virtue in staring at your screen for 2 hours trying to figure something out. That's what I did as an undergrad, and it was horrible. So I'm trying to fix that for you guys. So if you've been stuck for, let's set a time period. If you've been stuck for 30 minutes on a problem and you're still scratching your head, then that's when I want you to ask for help. Write something publicly in our CSCI 1 channel, ask me a private message, come to office hours, do something to get help, please. All right? 30 minutes, that's the time range. It is my job to answer your questions, get you over your current hurdle and on to the next one. All right? That being said, I set this class up in a way that you'll probably be spending 29 minutes on a lot of ideas, right? And then you'll have a flash of genius and get it. That's pretty much how critical thinking and computer science, computational thinking works. So that is what's going to happen in your mind. It takes a while, but then the answer comes to you, okay? So please get help when you need it. I can't say that enough, all right? I want to help. Any questions about any of that? Because that's most of the logistics. I wanna take attendance after all that. Are we ready for that? All right, let's do it. Let's prove that we're all here right now. If you added the class after Thursday, you might not have an account on here, but we'll make it work. So please go to this place. The link is also in Canvas. It's www.lottensclass.com. There's also a link on our homepage of Canvas, way down at the bottom here, class website. And it will ask you to log in. And so here's the homepage after you log in. But please go here and log in. Your username and your password right now are both the same. They are your last name, all lowercase, no spaces, no accent marks, no dashes. Just your last name jumbled together, all lowercase, plus an underscore, plus your student ID. All right? So your username and your password are both that right now. All right? So I want you to log in with that in mind. So if this is my last name, if this were my student ID, this would be my username and my password right now. If this were my last name and my student ID, this would be my username and my password right now. See, I'm getting rid of dashes, making everything lowercase. Okay? So try logging in on the class website, and I'll come around and help you. We're going to go to the attendance app, and this is going to be how we take attendance every day because why not? I made this nice website because I'm a computer scientist, and I don't want to call out your names or have you write on a sign-in sheet. Okay? So go here, get to this take attendance page. It won't work until I start the attendance, but you'll be able to click any of these and tell me that you're here eventually. So get here. If you get here early, like you can go to your name up in the top right and change your password. I recommend that. And then you'll just log in with the new password, same username. All right. So I'm going to stop here and come around and make sure we can all log in, and then we'll take attendance. I should probably log in myself. So just raise your hand if you're having trouble, if it's not working. I want us all to get to the attendance page.
There's no active attendance. Oh. Do we use these computers?
Don't use this. That's why we're in a computer lab. Alright. Anyone not being able to get in, speak now, be marked absent, and I have to drop you. We're all good. We're all going to be marked here and not dropped from the class. Alright. Cool. That was pretty problem 3. Good. So I'm going to start attendance in my little admin section. And then we'll go from there. So CSCI 1, begin, and now your responses should be taken. Oh, you having trouble? What's up? So type it, please. Show it to me. Just that again. No capitals. No capitals. Exactly what you typed there. That's your password. What's that? Oh, yeah. The power button should be the little alien. And then you can, I don't record which button you press, so just like whatever you're feeling that. Press it. And then, because I know we're all anxious people like me, view my attendance after that. If you go back to the home page, you can view your own attendance and just confirm that you were marked here. Okay? So, yeah. Did we all do it? Did we all click a button? We all marked here? Confirmed it? We're all not going to get dropped? There's exactly 18 of us here. Speak now. Or don't show up next time. Alright, I'm stopping the attendance now. And that's what we're going to do at the beginning of class every day. Okay? So that's much simpler. I don't know what your other professors do. I just made this for us. But hopefully it streamlines everything. So that's that. And now let's actually have a little bit of a lecture. We're going to have some just introductory things to start. I'll talk about what I like to do. In this class especially, I'm going to put you into small groups, just like ask you to like go sit, hang out with the people next to you. And I'll have you answer stuff in this by-clicker app. So you'll click here eventually, and it has like options A through E. Have we all taken like a large lecture class where you had to buy these iClicker things? And like they're like $60 just to press A through E. It's kind of disgusting. So I've made that for us for free. You're welcome. And it'll help me understand like where you're at. So I'll split you into groups, have you help each other learn. It's called peer instruction. If we're shy, I'm very shy. So I understand if it's a little uncomfortable to do this at the beginning, but I promise it's worth it. Every single study that's been done on peer instruction just proves that you guys teach each other better and you learn more rather than listening to me all day. So that's why we're doing it. Our first question is on the next slide, and I have a silly name that I give to our in-class exercises because some people abbreviate those as ICEs, and our mascot here at Clovis is the crush, which is a bowl, and I'm not sure how those words go together, but that means I'm going to be calling our in-class exercises crushed ices, obviously. So let's get started. Please open up your by-clicker page. I'll go to my admin version of it. I'm going to ask you guys some questions. So it'll help us understand the makeup of this class. So please tell me, what is your major? Just a simple question. Are you computer something? Are you engineering something other than computer engineering? Are you some kind of math? Are you a STEM major? Or are you something completely different? I'll give you a few seconds, since we're all logged in, right? I'll give you another few seconds to enter in your response. Let's see who's in this class. All right, I think there are 18 people here, so that's perfect. Nice, so a lot of us are computer science. I kind of expected that. Some of us are engineering. No math people. We gotta, you guys gotta advertise to your math major friends. We got one other STEM and a couple, something else. So I'm glad you're all here, especially the something else. Your perspective, here we are, just like STEM people. Your perspective is gonna make this class a whole lot better, I promise. So, yeah. And then computer science people, help your peers. Computer engineering people, help your peers if they're having trouble. So, yeah, that's who's in the class. I also want to ask another question. Boop. Have you ever programmed before? This is a class where I'm going to teach programming like every other lecture. I don't expect you to have ever programmed, but you tell me. Have you never done it? Maybe you've done it a little while ago. You're like a computer science major, so you just took a class on it last semester. Or like if I get that COVID that they said I was exposed to, could you teach the class as my replacement? Let's see how experienced we are here. Nice. All right, cool. So a decent amount of us have never programmed before, and you are exactly in the right spot. All right. I do not require you to have ever programmed before. I'm going to teach you from scratch in a language called Scratch. It's going to be great. A few of us have programmed before. To the one person who could teach this class, I guess we have to fight for who teaches next semester, right? Because it's probably how this works, right? All right. So I think that's everything. I just want to give us like a little short history lesson, then we'll talk about ethics. Are we ready for like real computer science? Like, have I answered all your questions? We good to go? Well, we got a few minutes left. We got at least half an hour left. Perfect. So let's talk about the history of computer science, shall we? Let's go back to the very beginning so that we understand where we are today. So I guess if you ask like some dictionary what computer is, a computer doesn't have to be electronic, right? It's a tool. It's a tool that helps you compute. So technically, the abacus, I would say, is the world's first computer. It was a little tool, got some pegs and some little discs, and you move them around and it helps you add, subtract, multiply, divide, if you want to be extra fancy. So this is a computational tool. And so back way thousands of years ago, over 4,000 years ago in the BC era, people were computing stuff. It was like the first computer. And then we obviously want to do more. And so we have to invent some new ideas. All right, so we have to fast forward all the way to the 1700s. People were happy enough with just doing math on paper for a while. Up to the 1700s, during the Renaissance, I guess, we have binary being invented. Have we heard of binary before? That is like what computers use to send around information. So binary, if you haven't heard of it before, we're going to have a whole lecture on it. It is a number system. It's just a number system like we count in the base 10 number system, because our digits go up to 0 through 9, 10 digits total. Binary is base 2. So the only digits that binary numbers have to work with, just like base 10, our decimal system has 0 through 9, this means if it's base 2, then you only got the numbers 0 through 1 to work with. So to count in binary means, all right, the number 0 is 0, the number 1 is 1, and then we've run out of digits. We have to write a new place now. So 1, 0 in binary must be the number 2. That's how we're going to count. And so people invented binary. This dude, Leibniz, Gottfried Wilhelm von Leibniz, if you've taken a calculus class, he's big there too. So while he wasn't inventing calculus, he invented binary and formal logic. It's really, really cool. So this is binary. And then this is another number system called hexadecimal, which we'll also learn. We have 16 digits, so we start using letters there. It's kind of cool. So that got invented, and then we want to make machines that do our bidding. So this guy named Charles Babbage, he created a device called the analytical engine, or he planned it. I don't think he finished it. He made a simpler version during his time, but I don't think he ever finished this analytical engine. But the idea of this is it was a computer. It was like the first real computer. It was using gears. Like you would program it, and then you start like rotating the gears like manually using your hand, and it would run your program to completion. And like, kind of what a program is, it's just a sequence of instructions. So like you could feed into this analytical engine the idea of like, all right, add the things that we put in the x and the y variables and put that answer into the z variable because I want to use it later. Like that's an instruction to this computer. Then like maybe you could say take the square root. I'll abbreviate that, of z that I just computed. Like that's an instruction. Run that one after that. And then like show z on the mechanical crankshaft output of this analytical engine because that was the answer I really wanted. I wanted that square root. So these are instructions that you could feed into this computer in a certain way. You like turn the crank and it spits out the answer. So that's like the first mechanical computer in the early 1800s, invented by Charles Babbage. Pretty cool. We've come pretty far since then. And then, a few years later, a woman who worked with him, her name was Ada Lovelace, and she was the world's first ever computer programmer. Because Babbage, he was like worried about making this thing. Ada Lovelace, she created the first program that would run on his analytical engine. Really, really cool. So if I zoom in, here's an example of the program that she made, the world's first program. It was a program to do some math and compute the Bernoulli numbers, which is used in statistics, if you've seen those before. But it's just like a series of computations to compute that. And so she came up with the exact right instructions to send to this analytical engine to do that computation, to compute these Bernoulli numbers, which is really, really cool. And then also, she just, like, if you go to her Wikipedia page, not only is she the world's first programmer, she just has such a cool life. So, first of all, she was a countess. She was a royalty. Augustus Ada King was her full name, Countess of Lovelace. Have we taken an English class before and learned about the author Lord Byron? Have we heard that name before? Maybe not. I did, I think. He had a lot of illegitimate children. She was the one legitimate child of his. So she just has a very interesting background. And to top it all off, she was the world's first programmer, which is great. So yeah, that is very, very important historical fact. And then electricity was around during this time, so I guess the eventual goal is to make an electrical computer that we don't have to like turn cranks for. In the 1850s, a very, very powerful idea was invented by a man named George Boole, and he came up with Boolean algebra, which was named after him. And so that's the idea of working with true and false, the idea of working with the number with like 1 for true and 0 for false, and performing operations with those things. Like there's an operation called the AND operation. You can take true and AND it with true, and apparently the answer is also true. And we'll talk about that. But sending these ideas, what is 1 and 0 but a binary number, right? Bits, individual binary number digits. This like paved the way. These ideas from George Boole, Boolean algebra, paved the way to create computers. This is an operation on Boolean values, and you can build up circuits with that idea. Like here is a piece that does the AND operation. Here's another piece that does the OR operation. And like you feed in inputs and create outputs. And the original reason that this was invented didn't have to do with electricity, really. Didn't have to do with creating a computer, but the idea spread. All right, Boolean algebra, this kind of idea of making circuits. All you need to build a processor, the important thing inside of your computer is some Boolean algebra, a very, very complicated Boolean algebra formula that describes the processor, and then a clock circuit. If we're engineers, maybe we've heard of that. That's all you need to describe a computer and create one. So it's a very powerful concept that we'll talk about. So that was invented in the 1850s. And then, at the same time, like Babbage kind of started it, people were thinking about what it means to make a computational tool, something that we could like what kinds of programs could we run on this analytical engine? What kinds of programs could any computer ever run? And so that's where Alan Turing came in. So please look him up. He had a very sad end to his life, unfortunately. Maybe we watched the movie about him. but he's a very, very smart man. He came up with a very cool idea called a Turing machine, named after himself. So that's a model of computation. I'll zoom in. There's a picture of him on the right. The idea of a Turing machine is like you have some information and you can describe like how to process that information. But any program, what he proved was that any program that any computer that's ever been made or ever will be made can be modeled with a Turing machine. And so if you prove something about a Turing machine, that means you've proven something about what is computable, right? This is really, really powerful. And they had this idea in the 30s. They didn't have very powerful computers yet, or any computers really, but they were thinking about what it means. What could a computer do if I built one and it had all this power? You can model our current day computers with Turing machines, right, and prove stuff about them. So at the same time, over in Germany, 1936, the Z3 computer, maybe it's Z3 because this is Europe, that was the first digital computer that ever got made. And so what they did, this is completely electric, no like spinning any cranks anymore. This was invented by a man named Konrad Zuse, and here's like a model version of it. And it was completely electric. The first computer that was completely electric. It used like vacuum tubes to do its bidding, but it was sending zeros or one throughout the computer, doing Boolean algebra to compute stuff. And so 0 and 1, you can model that in electricity with like the idea of off or on. And that's your false or your true, right? False or true. And if you're an engineer, it's like low voltage or high voltage, essentially, at the end of the day. And so that's how you build a computer, more or less. We'll talk a little bit about that. You'll have to wait till CSCI 45 if you really want to know this stuff. But that was the first digital computer. And then this like took up a giant room. Computers were very large for a while. People started making them. Then in the late 40s, in the US, the transistor was invented. All right. So this is like, if you ask anybody who's ever dealt with this or has ever learned about a transistor, most people say this was the greatest invention of all time because of what it's done for us, the way that it's improved our lives. So it was invented at Bell Labs. That was a telephone company. Of all places, this thing was invented at a telephone company because they wanted to like do the telephone switchboards automatically. It's kind of funny. But this is a transistor, and what it can do, it's a very simple device, but if you make a billion of them and put them in a chip, you can build a computer with them. So that's what our computers are built out of, transistors. What it can do is it can amplify a signal or function as a switch. Let me define both of those for you. So a transistor can amplify a signal. Maybe you've heard of transistor radios. What that means is like you've got a little signal coming in, wee, baby signal, and a transistor, if you feed that into a transistor hooked up to some extra power, it will amplify that same signal, make it more powerful, and that allows you to do some cool stuff like play the radio. Maybe, like I play guitar. Have we heard of electric guitars before? Do you know how they work? Let me just give you that in a second. Okay, so here's a silly, horrible drawing of an electric guitar. An electric guitar has one or more things called pickups inside of it, which are like listening to the vibrations of, they've got magnets inside, and then like this is hooked up to an amplifier. And the magnets in those pickups, as the metal wires of the guitar strings vibrate close to them, it generates an electric signal, magnetic flux, which turns it into an electrical signal, it turns it to like voltage and stuff. And if you send that into a transistor, and a lot of amplifiers, solid-state amplifiers, use transistors to amplify their signals, and that produces sound, because you got like a tiny little wave coming from the vibrating strings of this guitar, which like you can't hear from 5 feet away, and then you can shove this into a very powerful amplifier, and that creates a large signal. So transistors can do that for us, after you, of course, plug it into extra power. Plugged in. So a transistor can amplify a signal, and actually we don't care about any of this for computer science. That feature of a transistor is just kind of like an extra cool thing. We really care about, to make a computer, that a transistor can function as an electronic switch, which can be flipped on and off with electricity, which is really, really cool. So essentially, like you feed either low voltage or high voltage into a transistor, and like there's 2 wires. I'm not going to test you on this, by the way. So like if you feed low voltage into a transistor, it's like it's an open circuit, and so no power is flowing. So like if you feed a zero coming in this way, this is like closed off and it's not going to let power flow. Or if you feed a 1 in, it'll close off this circuit, and then it'll let power go through. And if you do this in a weird way, you can create memory, you can create computation. Okay, so that's the idea. So that's what transistors are. They're just electronic switches that you turn off with more electricity, turn on and off with different kinds of voltages, and that can create a computer, which is really awesome. But yeah, arguably the greatest invention of all time. People started making transistors smaller and smaller, and now we have phones with billions of them in them, like much more powerful than the giant supercomputers of the 50s, which is great. So it's really improved our lives. Then in the late 60s, people were like, we have these computers, let's make them talk to each other. And so ARPANET was created. It was a precursor to the internet, and so like the third place on the internet was all like schools connecting to each other. Really, the third node on the internet was where I went to grad school, UC Santa Barbara, but of course I didn't take a networking class there, sadly. But yeah, this was like the precursor to the internet. Now we're starting to hook computers together and have them talk to each other, and we all know how nice that is, right? That gives us the internet and everything. But still, during this time, computers were giant. They were in rooms, and then people had to like share time on them. They weren't really in anybody's house yet. They were very expensive. And so with transistors becoming smaller and smaller, eventually we get to the mid-70s, and the company Apple was created by two guys, Steve Wozniak and Steve Jobs. Steve Wozniak did all the real work, by the way. But they created what's called the Apple I, which was like, I would consider that to be one of the first personal computers. It was small, it was in a box, and you could program it to do whatever you wanted. It was very slow, of course. But nobody really at this time was thinking about, like, I would like a computer in my home. That didn't make any sense to people. But now it's a very, very important idea. Yeah. So it didn't used to be like that. And then, of course, computers got faster and smaller, and they're everywhere now, and they're all interconnected. So that's pretty much my history lesson for us. Before I talk about something completely different, I do just want to take a slide to say that computer science is not just a bunch of dudes, because there is that false assumption that I hear a lot. So let me just take this slide to talk about 4 very important women in computer science. If you've never heard about them, get ready to have your mind blown. So the first one, Grace Hopper, or to be more precise, she was Rear Admiral Grace Hopper. She was in the Navy, and she made some serious contributions to programming languages and compilers. You'll learn more about what that second word means in another computer science class. But she's very, very influential. A lot of programming languages these days have her to thank for the way that they're structured. And she was also the first person to use the word bug about software. So we have her to thank because we use the word bug all the time, even informally, don't we? So there's that. Sophie Wilson, she helped design the ARM architecture, which is the architecture that every phone is using these days. So we have her to thank for small, power-efficient processors. That was not a common thing back then, okay? Back when she was co-developing that. On the more mathematical side, we have Shafi Goldwasser, I think is how we pronounce her name. Back in 2012, she won what was called the Turing Award for what she did in cryptography. Have we heard of the Turing Award before? It's the equivalent of the Nobel Prize for computer science. So it's like the highest award you could possibly get. It's a huge honor. You get $1 million if you win it. And she did a very, very important, she did some really, really cool research that I could not even hope to explain. But something that she worked on was called fully homomorphic encryption. And if we can ever get that to scale, it's going to be a very, very powerful thing if you want to look that up and look her up. So she won essentially the Nobel Prize of Computer Science, and plenty of other women have. And then finally, if you've never seen any of these other people before, you've probably seen this this picture floating around the internet. This is Margaret Hamilton. She was the leader of the team that created the software for the Apollo program. The first, like Apollo 11, used her software, for example. We have her to thank for getting to the moon, okay? So it's a big, big deal. And here she is. This is a very iconic photo. She's standing next to a printout of all the code that was written for the lunar lander. So they printed it all out, and she directed the team that built all this code. Amazing. Amazing work. So, yeah, just want to say, just for a second, it's not a bunch of dudes. And, of course, the very first programmer was Ada Lovelace as well. So, yeah, with that, that was our history lesson of the day. Are we ready to completely switch gears and talk about ethics? Because we have the other half of this class, essentially, philosophy. Computer science plus philosophy. So, yeah, let's talk about ethics and try to apply it to issues. If you've taken a philosophy class, maybe you've seen this before, and you can help me. If you have, if I say something wrong, you can fix it. You can yell at me. So here are 3 questions that are ethical questions. All right. First one: is it okay to steal to feed your family? Imagine you had no other way of getting food. There's nothing. Nobody was going to give any to you in any way. You were starving and your family was starving. Would you steal to feed your family at that point? Question to just ponder in your mind right now. Just imagine there was no other alternative. That was the only way you could get food, and you had a family to take care of. Would you steal? Another question that's more of an open-ended question is has to do with privacy. How much privacy should we expect from our government, from the websites we go to? You've seen all these, do you accept these cookies questions in a lot of days nowadays because of some laws that were passed in the EU? What is guaranteed? What do you imagine is our right? It depends on the country too. So that's another open-ended question. And then finally, very standard, it's called the trolley problem. Maybe you've heard of this before. It's is it right to kill one person if it means you're going to save 50 people? There's a train coming on tracks and you can divert the train. Right now it's going to ram into 50 people, but there's another one person tied on the other tracks. Would you pull the lever and kill the one person rather than letting the train just maul through the 50 and kill all of them? So again, it's an ethical question. And what we're going to learn about in this class is how to come up with a good argument. Arguments. It's going to be half the class, learning about what it means to make a good argument. There are different adjectives you can use to describe a good argument. You can say that an argument is sound. You can say that it's valid. There are other words, it has a fallacy in it, etc., etc. But as far as these ethical questions are concerned, there is no right answer. So in this class, when I ask you to write something, as I am forced to, I don't really care what you say as long as you explain it properly and analyze it well and do some good analysis. Because there really is no right answer to any of these questions, right? Absolutely not. It depends. And you need to tell me which way you think in your own mind and use some of the tools that we're going to learn about in this class to use as firepower, right? To convince me, the person who's grading your essay, right? Any questions about that? Because this is completely different to a math class where there is always a right answer. This might be new to us, and it will rack your brain for a while, okay? So, does that make sense? There is no right answer. We have to grapple with that, right? So with that, I have an assignment for you that I'll release now on Canvas. Let's go to it. It is going to be your first little essay. I'm going to start us off small. We have to get 6,000 disgusting words by the end of the semester. I'm not excited to grade them, just as you're not excited to write them, but we have to do it. So this is your first mini essay. It's going to be very, very short, only 250 words, and it is now released on Canvas if you'd like to go to it. But here it is. It's essentially those questions. I want to see where you're at. So in 250 words, you're starting us out small. Please respond to both of these questions. So you got to write both. You got to answer them both. If you need more than 250 words, so be it. But I want to see answers to both of these in some nice styled way. Is it okay to steal to feed your family? Tell me yes or no. Explain why. Why not? Is it right to kill one person if it means you're going to save 50 people? Tell me yes or no. Explain why or why not. Okay? So I want you to explain those answers and mention why you don't agree with the other side's argument. Because one big thing about argumentation is if you say yes, it's okay to steal to feed your family, you have to tell me why you wouldn't have said no. Why the people who are saying no, if they say no, it's not okay, tell me why they're wrong. That's what it means to write a good argument. You're exploring all the sides, right? That's important. And then again, there's no right answer. So I don't care which side you pick, but you have to give reasons, talk about the other side, bash them down, and argue your points. Make it convincing. All right? So that's your first mini essay. It'll be due in a week. So the 16th. So next Tuesday, a week and a day from now, 5 p.m. Any questions about that? So that's going to be your first assignment, starting us off small. Yeah, question.
Is there specific format we need to follow, or just type it out in the text box?
No, you just type it out. I think I'm only allowing you to type in the text box this time because it's so short. But I'll have some style guidelines for future essays. Yeah. Any other questions? All right. So yeah, make a post with at least 250 words. Remember that due date. Don't let that slip by. And then finally, what I would like to do is get us into peer instruction groups for the day for a few more minutes. I'll give you 5 minutes. What I'd like you to do before, let me explain it first before I have you do it. But I would like you to go, like, maybe pick the row that you're sitting in, find a couple people, 2 or 3 people, or just like use the entire row. People sit next to you, say hello, introduce yourself, and then I'm going to put this slide back up. Pick a couple questions, maybe the ones that you're going to eventually write about. Pick some questions from that slide and come up with 2 arguments for, in favor of doing that thing, and 2 arguments against doing that thing, because you're going to have to think about how the other side would consider stuff, because you have to bash down that side, right? So come up with 2 arguments for and 2 arguments against. So like come up with 2 arguments for yes, it's okay to steal. 2 arguments for no, it's not okay to steal. So you need to think about both sides, all right? For the privacy question, let's say that like 4 means you have a lot of privacy. And you don't have to write this down anywhere. Just want you to discuss as a group, come up with some good ideas, and you can use those on your essay. So I'm going to go back to this slide, take like 5 minutes, introduce yourself to your peer instruction group, say hi, and then come up with 2 arguments for and 2 arguments against a couple of these questions. Okay? About 1 more minute to discuss. Alright, that's my timer. Let's come back together, please. You guys can talk in just a few minutes. I'm pretty much almost done. You can go back and discuss some more, but let's come back together. Normally, I'd have you like write down your answers somewhere, like I've made a page for that. But this, you can save your answers for your essay. That's where you'll be writing them down this time. Okay. So I hope that was useful to you. We're going to do that a lot in this class. Oh no, I'm not asking you that on your essay. So I want you to answer both of these specific questions. Yeah. This was another one to consider, though. Well, that'll feed into the rest of the class. I have some lectures on that, too. So, yeah, good question. Any other questions before I say a couple last things? So that's your first assignment. That's when it will be due, and I'm going to post everything that we did today in this lecture 1 thing on Canvas after I've got it all ready. So that will eventually appear, and then next time we're going to talk about programming. Okay, so that's that, and this class ends at 5:15 usually, always, but usually I'll be done like 10 minutes or so before class, and so the lecture is over now. I'm still required to be here, but the class is not. All right, so I'm not going to say like let's all pack up and go home now. If you're done with all your work, you totally can, but I'm going to like bake extra time into this class for you to like come up and ask me questions, do work while I'm around to ask questions if you run into problems, stuff like that. This is just like extra office hours essentially after class is over. So I'll be here until the end of time. I'm not just ending the class and leaving. All right, I want to make sure that is clear. If you finished all your work, you're absolutely free to go. All right, but you have 10 extra minutes or 9 extra minutes in the class, and I'm not going to kick you all out right now. Okay, so that's going to be usually how I run my lectures. All right. So yeah, without any further ado, that is the end of the lecture time for this class, and I'll just be hanging out for the rest of the 8 minutes that we're still in here.